Sequences. The learning target for this video, I can define a sequence and complete a pattern in a given sequences. These are the guide questions for you to be guided of the things you will be learning out of this video. First, what is a sequence? Second, what is a finite sequence? At the same time, what is an infinite sequence? How do we list terms in a sequence? And lastly, what do we call an order of numbers that exhibit a pattern? Now, as mentioned a while ago, pattern, it's number or shapes or objects that are arranged according to a rule. These are some of the examples. First, as you can see, I use shapes to indicate a particular pattern. And aside from that, another example, we have 1, 2, 4, 7, and 11. So we are going to focus with the second example, and this is called a number sequence. By the way, what is a number sequence? So it is a list of numbers having a first number, a second number, a third number, and so on. Those numbers are called terms of the sequence. Again, you take note of this very important word. So the numbers in a particular sequence is or are called terms. Next, we have sequence, guys, is a set of values that follow a particular order, and a sequence can be finite or infinite. Now, what is a finite sequence? So finite sequence, it's having a finite number of terms. So example, we have this 2, 4, 8, 16, and 32. Now, by the way, how will you write a sequence? So we are writing a sequence in this way. So term, and then comma, then another term, then comma, then another term, and comma. That means terms are separated by comma. Okay, next we have infinite sequence. It's a sequence that has an infinite number of terms. Example for this is this one. But as you can see, what's the difference between infinite and finite sequence? For infinite sequence, we have this 3 dots, or the what we call ellipsis. So this ellipsis means that the sequence goes infinitely. So that means in our second example for infinite sequence, we have 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and so on. So that is infinite sequence. Now, as mentioned a while ago, term, this is the value in a sequence. So here we have our example a while ago, 5, 6, 7, 8, 9. And so as you can see in our example, we do have a lot of terms, but to be specific, 5 there is considered as our first term, 6 is our second term, 7 is our third term, and so on. So again, I just would like to reiterate, as you can see, we do have there a ellipsis. That means this sequence is infinite. Okay, now, so in our example, we do have 5, 6, 7, 8, 9. So we do have first term is 5, second term is 6, third term is 7, fourth term is 8, fifth term is 9. But what if I asked you to identify the 100th term of this sequence? So it's really hard for us, right? So we need the idea of this nth term, or what we called as the general term of the sequence. And in this case, since we do have our sequence 5, 6, 7, 8, 9, our nth term or general term for the sequence is n plus 4. So again, the general term of the sequence is n plus 4. Aside from that, in other books, we use the word explicit formula of the sequence. So again, the explicit formula of the sequence is n plus 4. Now, I'm going to tell you or share to you on how to make an explicit formula or the general term of the sequence on the next video. But for now, to check if our n term of the sequence or the general term or the explicit formula of the sequence is correct, so we have n plus 4. For us to check, you just simply evaluate the given formula. So n plus 4, so if we refer to our terms given, so the first term there is 5. So 5, so that means since 5 is the first term, now let's check. So since it's first term, we are going to substitute the n, this one. So by 1, since it's the first term, so 1 plus 4, it's 5. So it's correct. So if we're going to check the second term, so we just simply substitute the n by 2. So 2 plus 4, it's 6. It's correct. And for the third term, so 3 plus 4, it's 7. And fourth term, 4 plus 4, it's 8. And so on. So that means the explicit formula or the general term or the n term of the sequence stated here, n plus 4, is correct. So now I just would like you to take note of this following information. So the term or terms of a sequence can be found using a pattern. So just simply looking at the pattern or observing at the pattern, you will be able to get the terms in the given sequence. And aside from that, you will be able to identify also the terms or term of a particular sequence by evaluating algebraic expression, somewhat like in the nth term or the explicit formula a while ago, wherein you just simply substitute the value of n or the value of any variable in the given formula or n term. And next, when we write an infinite sequence involving a specified set of numbers, we put ellipses or 3 dots to indicate that the sequence goes on infinitely. So take note of that. Okay, so as mentioned a while ago, I would like you to find the next 2 terms of a sequence by simply observing and looking at the pattern on the given sequence. So first item, we have 6, 11, 16, 21. What do you think are the next 2 terms of the given sequence? In this scenario, so as you can see, our answer is 26 and 31. Why? Because we just simply add 5 to the previous term to get the next term or the succeeding term. So 6 plus 5, we have 11. 11 plus 5, we have 16. 16 plus 5, we have 21. Therefore, 21 plus 5 is 26, and 26 plus 5 is 31. Okay, next example, we have 13, 5, negative 3, negative 11. So what do you think will be the next 2 terms of this given sequence? So observe. So the pattern in the given sequence is simply subtract it by 8. Or you may add negative 8. So maybe I'll just use subtract it by 8. So 13 minus 8 is 5. 5 minus 8 is negative 3. Negative 3 minus 8 is negative 11. Negative 11 minus 8 is negative 19. And negative 19 minus 8 is negative 27. Okay, let's proceed to our third example. So we have 32, negative 8, 2, and so on. Now, what do you think is our pattern, our third example? So actually, our answer is negative 1/2 and 1/8. So here, how did we get negative 1/2 and 8? So the pattern is simply divide the previous term by negative 4 to get the next term or the succeeding term. So 32 divided by negative 4, so we'll have negative 8. Negative 8 divided by negative 4 will have 2. And then 2 divided by negative 4 will have negative 1/2. And negative 1/2 divided by negative 4 is 1/8. So by the way, you can also use multiplication here. So you may have 32 times negative 1/4, then negative 8 times negative 1/4, and then 2 times negative 1/4, and so on. Okay, next practice exercise will be list all the indicated terms of each finite sequence. So as you can see, we do have here the general term or the nth term of the given sequence, which is 2n plus 1. So we are asked to find out the terms given that n is greater than 1 but less than 5. So what do you think are the values of n that is greater than 1 but less than 5? So you think of those numbers which are considered, it's a whole number that is considered greater than 1 but less than 5. So what are those possible numbers? So we have 2, 3, and 4. Okay, so now let's have here 2n plus 1. So again, so according to the indicated scenario given in the problem a while ago, so n must be greater than 1 but less than 5. So those are possible values of n would be 2, 3, and 4. So substituting, we'll have a sub n equals 2n plus 1, the given n terms or the general term. So you just simply substitute 2 here for n. So we have 2 times 2 plus 1 will have 4 plus 1, a sub 2 equals 5. By the way, I just would like to emphasize this. If we substitute 2 in the given general term, you need to change also the a sub n there in the given equation. Instead, n must be 2 at the same time since you substituted 2. So that refers to the second term already. A sub 2 equals 5. Next, for 3, we have again rewrite the given explicit formula. So, and then of course we need to change the a sub n to a sub 3, and then therefore substitute 3 to the n in the given equation. So we have 2 times 3 plus 1 will have 6 plus 1 will have 7. So a sub 3 equals 7. And lastly, for 4, same, rewrite the given general term and then substitute the 4 to all the n's in the formula or in the equation, and then simplify. 2 times 4, 8 plus 1 will have a sub 4 equals 9. So we're done with our first problem. So therefore our answers would be 5, 7, and 9. Next, again, list all the indicated terms of each finite sequence given that n is greater than 4 but less than 7. So you think again, what are those whole numbers which are greater than 4 but less than 7? So we have 5 and 6. Okay, so therefore we substitute now in our general term. So we have, again, rewrite our general term. A sub n equals 2 raised to n minus 5, and substitute first the 5 to all the n's in the equation. So therefore we have a sub 5 equals 2 raised to 5 minus 5, and simplifying, 2 raised to 5 2 times 2 times 2 times 2 times 2 will have 32. Then minus 5, we do have a sub 5 equals 27. And next, for 6, we substitute 6 to all the n's in the given equation. So that means 2 raised to 6 is equal to 64. Then minus 5 will get a sub 6 equals 59. So therefore, our answer is, or are, 27 and 59. Okay. Next problem, or next item, we are going to list again all the indicated terms of each finite sequence given that n is greater than or equal to 1 but less than or equal to 4. So, what are those possible values of n given it's a whole number, positive whole numbers, which are greater than or equal to 1 but less than or equal to 4? So, we have 1, 2, 3, and 4, but of course we are going to do it one by one. Let's start with 1 and 2. So, substituting 1 in our given equation, so we have changing all the n's in the equation by 1, so we'll have a sub 1 equals 3 times 1 raised to 2 minus 1. So here, simplifying, 1 raised to 2 is 1. Then 3 times 1 is 3. 3 minus 1 will have 2. So a sub 1 equals 2. And for n equals 2, so substituting, we'll have a sub 2 equals 3 times 2 squared minus 1. So we'll have 3 times 4 minus 1. So 3 times 4 is 12. Then 12 minus 1 equals 11. So our first answers are 2 and 11. So here for the next values of n, which is 3 and 4. So let's do it again one by one. So substituting 3 in our equation, we'll have all the n's must be replaced by 3. So a sub 3 equals 3 times 3 squared minus 1. So we'll have 3 times 9 minus 1. So we'll have 27 minus 1 equals a sub 3 equals 26. Next, for 4, we replace all the n's in the given equation by 4. So we'll have 3 times 16 minus 1. So we'll have 48 minus 1. So a sub 4 equals 47. Okay. Next, same process, list all the indicated terms of each finite sequence. So here our general term is a sub n equals 1 over n minus 1. So for n is greater than or equal to 2 but less than or equal to 5. So what are those possible values of n given that it's a positive whole numbers which are greater than or equal to 2 but less than or equal to 5? So what are those numbers? So of course we're going to start with 2 because here in our rule it's greater than or equal to 2. So 2, 3, 4, 5. So 5 is also included for the value of n because of in the given rule it's less than or equal to 5. So 5 is also included. So let's start with 2 and 3. So again, same process, we will change all the n's in the given equation by 2. So we have here a sub 2 equals 1 divided by 2 minus 1. So 1, simplifying, 1 over 1, it's equal to 1. So a sub 2 equals 1. And for 3, we have, of course, change all the n's in the equation by 3. So a sub 3 equals 1 over 3 minus 1. So simplifying the denominator, so 1 over 2. So that is our a sub 3. It's equal to 1/2. Next, for the fourth and fifth term or value, we have a sub n equals 1 over n minus 1. So change all the n's by 4. So we'll end up with a sub 4 equals 1/3. And for the 5, so just simply substitute again. And simplifying, we'll end up with a sub 5 equals 1/4. Okay, so let's have here your another practice exercise to check if you really understand the content of this video. So list the indicated terms of each finite sequence. So we have here a sub n equals 2n plus 5 for n is greater than or equal to 1 but less than or equal to 4, and we have a sub n equals n over n plus 2 for n is greater than or equal to 3 but less than or equal to 6. So your answers must be written in sequence pattern. So I would like you to write all your answers as a set. So our answers for the formative assessment a while ago, we have for the first item, so a sub n equals 2n plus 5. Your answers are 7, 9, 11, and 13. And next, in our second general term, we have a sub n equals n over n plus 2. So our answers are 3/5, 2/3, 5/7, and 3/4. Okay, but of course, I'm providing you another set of activity so that to double check if you really master already the content of this video. So I'd like you to answer these 3 items. Let's check if you can answer all these items correctly. And for the answer key of our group activity or additional practice exercise, so for room 1, the answer is 0, 1, 4, 9. And for room 2, we have 2, 7, 12, 17, 22. And for room 3, since we are asked to find the 8th term of the given general term of a sequence, so a sub 8 equals 12. So that's it. So thank you so much for watching this video. I hope you learned a lot out of this video. So guys, don't forget to subscribe now. Thank you for watching.